Today we talk about chapter 11. The title is chi-square test. And we will talk about the goodness of fit table and the contingency table. Chi-square test. Here we talk about the homework examples. Here, chapter 11 formulas. First formula, chi-square test for goodness of fit. Formula is chi-square equals summation O, means observed frequency, minus E. E is expect frequency, squared, over E. Degree of freedom is K minus 1. K is the number of categories. And the second formula is chi-square test for independence and homogeneity of proportions for a contingency table with R rows and C columns. The formula is chi-square equals summation O minus E squared over E. Degree of freedom is row. R is a row. Number of how many rows? R minus 1 times C is a column. Number of columns minus 1. O is observed frequency. E is expect frequency. And over E. And the expect frequency, how to figure out, is a row sum times column sum over grand total sum. I will show you examples later. The first formula is a chi-square goodness of fit test is used to test the claim that an observed frequency distribution fits some given expected frequency distribution. When the observed values and the expected values are close together, the chi-square test value will be small. Then the decision will be to not reject the null hypothesis. Hence, null hypothesis is good fit. When the observed value and the expected value are far apart, the chi-square test value, which is this, O and E are far apart, then chi-square value will be large. So the chi-square test value will be large. Then the null hypothesis will be reject. Large. Chi-square is large, then reject the null hypothesis. So suppose H1. So H1 is not a good fit. So H0 is a good fit. When the O and the observed value and the expected value are close to each other, O minus E is small. So chi-square is small. So when chi-square is small, then suppose H0. So we set H0 is a good fit. And H1 is not a good fit. The first question, example. A sample of 100 people provided data on their preferences among 5 flavors of soda. Soda with flavor. Cherry has 32 people like flavored cherry. Strawberry have 28 people. Orange have 16 people like orange flavor. Have 14 people like lime flavor. Have 10 people like grape flavor. And add those together, total 100 people. Those are the we call how many people is frequency observed, which is our O value. Is there enough evidence to reject the claim that there is no preference? When there are no preference means cherry and strawberry, orange and lime and grape, they are equal preference. People like those flavors 1, 2, 3, 4, 5. They are equal chance. So claim that there's no preference in the selection of food soda flavors at alpha equals 0.05. So use 5 steps for hypothesis testing. First step, state the hypothesis and identify claim. H0 is consumer show no preferences for flavors. This is a claim because the claim there's no preference. So indicate this is a claim. And H1 is consumer show a preference. They are not equal chance. The H0 is no preference. They are equal chance. H1 they have a preference. So step 2, find the critical values. The degree of freedom is a total 5, n minus 1. 5 minus 1 is a 4. Alpha is 0.05. So use chi-square table. Chi-square table. Now, for the chi-square table will be this one, chi-square table. Degree of freedom is 0.05. N minus 1, a degree of freedom is 4. Alpha is 0.05. So we look at 0.05. Degree of freedom is 4. It's 4. Here, this is alpha, this area. This area is alpha. Alpha is 0.05. Figure out this critical values. Degree of freedom is 4. Alpha is 0.05. Get critical value 9.488. 0.05 go down to 5 minus 1, 4 degree of freedom. This intersection 9.488. Use this chi-square distribution table. Find 9.488 right side, on the right side. The critical from chi-square table is 9.488. Then compute the test value. The test value, we will use the formula. We will use this formula. We need to find out O observed. O is given, and we need to find out E. And find out chi-square. This is a test value. So first of all, we created this table. Compute the test value. The expected value are found to be what? To be expected value equal. They are equally. So is E is N is total. It's 100 divided by 5 is 20. So since H0 is show no preference for flavors, so there 20 people like cherry, 20 people like strawberry, 20 people, each category have 20 peoples. So 100 divided by 5 categories. So expected value should be 20. So observed value is given. Expected value is n over k. K is how many category? 5 category. So expected value is 20. Then plug this number into the formula. Chi-square test. This use chi-square test. Chi-square test. Chi-square equals summation always observed minus expect is 20. First one is 32 minus 20 square over E is 20 plus. Second one is 28 for strawberry, has 28 people, minus 20 over E, 20. And the third one is orange, has 16 people, 16 minus 20 square over 20 plus. Then line has 14 people, minus 20 square over expected value 20 plus. Grape is 10 people, 10 minus 20 parentheses square over 20. Use this. 32 minus 20 square divided by 20. 28 minus 20 square divided by 20. 16 minus 20 square divided by 20. 14 minus 20 square divided by 20. 10 minus 20 square divided by 20, which is this over here. And use calculator, figure out. This is the test value, it's 18. And for chi-square is always positive. This is chi-square, and this, and started at 0, and this chi-square curve. And here, alpha is 0.05, totally go to the right tail. And we already figured out critical value is 9.488. In step 2, we figure out 9.488. Now, test value is 18. 18 is more than 9.488, is to the right of 9.488, so it's over here. So it's falling in this critical region, which is the rejection region. So we reject H0, suppose H1. So here, reject H0. Make a decision. Step 4. Step 5, suppose H1. So summarize the result. And because this claim is, this is the claim. Claim is want to say no preference is the claim. So H0 is claim since we reject H0. So therefore, there is sufficient sample evidence to reject the claim. So there is sufficient evidence to reject the claim that consumers show no preference for the flavors. Question 2, we always summarize the result, have stick with the claim. The claim is H0 and reject H0, so we say the sample evidence supposed to reject the claim. The claim is show no preference for the flavors. Second question, a Census Bureau of U.S. government found that 13% adults did not finish high school. 30% graduate from high school only. 29% had some college education, but did not obtain a bachelor degree. And 28% were college graduates. And to see if these proportions were consistent with those people who lived in the Lincoln County area, a local researcher selected a random sample of 300 adults and found that the 43 did not finish high school, 76 were high school graduates only, 96 had some college education, and 85 were college graduates. At alpha 0.10, test the claim that the proportions are the same for the adults in the Lincoln County as those stated by the Census Bureau. So first of all, step 1, state the hypothesis and identify claim. Hypothesis H0 is the proportion of people in category is as follows, which is 13% did not finish high school, 30% were high school graduates only, 29% has some college education but did not graduate. And next one is 28% were had college degrees. And this is the claim, because one test the claim whether the sample has the same proportion as the population. So this is the claim. One test is the same proportion, same percentage. H1 is the distribution is not the same as stated in the null hypothesis. It's not same as percent in the Census Bureau. Step 2, find the critical value, 1 alpha equals 0.10. Degree of freedom, because there are 4 categories. Didn't finish high school graduates, some colleges, but not graduate, and college graduate, 1, 2, 3, 4, 4 categories. So degree of freedom is K minus 1. 4 category minus 1 is 3. Alpha is 0.10. And hence the critical value from the chi-square table. So look at the chi-square table. 0.10. 0.10 degree of freedom is 3, and alpha is 0.10 is 6.251. So we got critical value from chi-square table is 6.251. Step 3, compute the test value. Compute test value, we will use this. This we call a goodness of fit formula. Chi-square test for goodness of fit. Use this formula. In this formula, we need to figure out E, expect value. Always observed value is given already. Here's given from the question. From the question, say 300 have 43 not finished high school, has 76 high school graduate, has 96 have a college education but not graduate, have 85 is a college graduate. So those are all observed value. Expect value is 300 times by 13%. 13% did not finish high school. Time together gets 39. So the get 39 is the expect value. And 300 is N times by 30% high school graduate. Times 30% got 90. So high school graduate expect value is 90. E is 90. And have 29% for some college education but did not graduate. So 29% times 300 get 87. So 87 is the expect value for some college but not graduate. And the last one, 28% times 300 and get 84. So 84 is the expect value for a college graduate. And the 2 subtraction, 43 minus 39 squared over E is 39 expect value, plus 76 minus 90 squared over expect value 90, plus 96 minus 87 squared over expect value 87, plus 85 minus 84 squared over 84. Add those together, use calculator, figure out is 3.531 and round it to 3 decimal digits. Get expect value. Get the test value is 3.531. Now for the curve, the 0.10 total to the right of this chi-square curve. This critical value is 6.251. Test value is 3.531, is less than 6.251, is to the left of So it's not falling in critical region. This is a rejection region. So it's do not reject H0. So make the decisions fail to reject H0. So it's support H0. So therefore there is not so it's for H0. Do not reject H0. So there is not sufficient evidence to reject this claim, H0. H0, it can be concluded that the percentage are not significantly different from those given in the null hypothesis. The sample percentage for the sample is equal as the census. That is, the proportion are not significantly different from those stated by the U.S. Census Bureau. Also, the next one is a chi-square independent test. Is used to test whether two variables are independent of each other. H0, if two variables are independent of each other. Alternate hypothesis, H1 is variables are dependent of each other. The data for the two variables are placed in a contingency table, row by column table. Contingency table is a row by column table, or R by C table. And where R is the number of rows and C is the number of columns. If there is little difference between the observed values and the expected values, then the value of the test statistics will be small and the null hypothesis will not be rejected. Hence, the variables are independent of each other. Small, because chi-square is small, reject null hypothesis. And there's no difference, and so they are independent to each other. The variables are independent to each other. Next one. If there is a large difference in the observed value and the expected values, then the test statistics will be large and the null hypothesis will be rejected. Hence, there is sufficient evidence to say that the variables are dependent on or related to each other. Question 3. A researcher wishes to see if there is a relationship between the hospital. Here has hospital A, B, C, 3 hospitals, and the number of patients, infections. Then this is ABC hospitals have 3 infections, surgical site infections, pneumonia infections, bloodstream infections, 3 infections, 3 hospitals. There's a 3 row, ABC, 3 hospitals, 3 column, 3 kind of infections, 3 by 3. A random sample of 3 hospitals was selected, and the number of infections for a specific year has been reported. The data are shown here. This is a hospital A, has a surgical site infection is 41 people. Hospital B has pneumonia infections is 3 people. And bloodstream infection is hospital C have bloodstream infection is 109 people. And the test for alpha equals 0.05. Can it be concluded that the number of infection is related to the hospital where they occurred? Related, which is dependent. So dependent is the claim. H1 is the claim. So First step, state the hypothesis and identify the claim. Null hypothesis H0 is the number of infections is independent of hospital. They don't have any relation, so it's independent. H1 is have a relationship, which is dependent. So the number of infection is dependent of the hospital. H1 is the claim. Step 2. Find the critical values. The degree of freedom is number of row, which is 3 minus 1, times number of column, 3 column, 3 minus 1. So 2 times 2 is 4. Degree of freedom is 4. Alpha is 0.05. So for 0.05, use chi-square table. Alpha 0.05, degree of freedom is 4. Intersection is 9.488. It's a critical value. It's 9.488. 9.488 is critical value. Then step 3, compute the test value. Compute the test value and use expected value. What is expected value? Expected value is row sum times column sum over grand total. Now, what is the row sum? Row, this is the first row. 41 add 27 add 51 and get 119. That's the first row sum. Second row, 36 add 3 add 40. The sum is 79. The second row sum. Third row, 169 add 106 add 109. Total 384. So those three numbers are row sum. Column sum is a column. Add together. 41 add 36 add 169 is 246 is the first column. Second column, 27 add 3 add 106 is 136. And the third column, 51 add 40 add 109 get 200. So those three are column sum. Now, if the total grand sum is 246 add 136 add 200, total is 582. And if you do the three row sum add together, 119 add 79 add 384 is also 582. And this is the grand total sum. If independent means expected value. This over this is a percentage. Percentage. This, the row 119 divided by total 582 is a percent. This percent times this percent times 246 over 582. This percent times this percent should be equal this percent is 41. Expected value of this one over 582. If they are independent is this percentage 119 over total percent times this percent should be